You need a server. On premises, this means purchase hardware, wait for delivery, rack and cable it, install an operating system, configure networking, set up monitoring, implement security controls, document everything. Weeks of work, thousands of dollars, multiple teams coordinating. In the cloud, you open a console, select T3.medium, click launch, and 90 seconds later, you have a running server. Same capabilities. No hardware, no waiting, no physical installation. What just happened? You interacted with an abstraction. The complexity didn't disappear, it's hidden. Somewhere, physical hardware was allocated, an operating system was deployed, network configurations were applied, storage was attached, but you didn't see any of it. You saw a simplified interface that made the complex look trivial. This is abstraction, and it's the foundation of everything cloud computing does. Understanding it is fundamental to understanding cloud itself. Abstraction in cloud computing is the process of hiding implementation complexity behind simplified interfaces. You interact with logical concepts, virtual machines, storage buckets, databases, while the provider handles the physical reality underneath. Think of it like driving a car. You use an abstraction, steering wheel, pedals, gear shift. These controls abstract away the complexity of the engine, transmission, fuel injection, electrical systems, and hundreds of other components. You don't need to understand internal combustion to drive. The abstraction lets you focus on driving while hiding mechanical complexity. Cloud computing works the same way. When you provision a VM, you're using an abstraction that hides server hardware, hypervisors, network infrastructure, storage systems, and data center operations. When you upload a file to object storage, you're using an abstraction that hides redundancy mechanisms, erasure coding, geographic replication, and disk management. Abstraction has two components: what you see, the interface, and what you don't see, the implementation. The interface is designed to be simple, logical, and focused on what you want to accomplish. The implementation handles all the complexity required to actually make that happen. The power of abstraction is that it lets you work at a higher level without needing to understand or manage lower levels. The danger of abstraction is that you don't understand or control what's happening underneath until something breaks and you need to. Abstraction isn't just convenience, it solves fundamental problems that make cloud computing possible. First, it reduces operational burden. Managing physical infrastructure requires specialized knowledge, dedicated teams, and constant attention. Most organizations don't want to be in the data center business, they want to run applications. Abstraction lets them offload infrastructure complexity to providers who specialize in it. Second, it enables scale. A provider can optimize infrastructure across millions of customers in ways that aren't possible for individual organizations. Shared resource pools, automated management, economies of scale. These only work because abstraction separates logical resources from physical resources that can be shared and optimized. Third, it accelerates speed. Without abstraction, provisioning infrastructure takes days or weeks. With abstraction, it takes seconds or minutes. The speed comes from having pre-built, automated systems hidden behind simple interfaces. You're not waiting for procurement and installation, you're consuming pre-existing capacity. Fourth, it standardizes interfaces. Different hardware has different management interfaces. Different storage systems work differently. Abstraction creates consistent APIs and controls across diverse underlying implementations. You learn one interface that works everywhere, regardless of what's actually running underneath. And finally, it enables innovation at different layers independently. The provider can upgrade physical infrastructure without changing the abstractions you use. You can modify your applications without needing to understand infrastructure changes. Abstraction creates separation that lets each layer evolve independently. Abstraction exists at every layer of cloud computing, each hiding different types of complexity. Infrastructure abstraction hides physical hardware. Virtual machines abstract physical servers. You get compute, memory, and storage without touching hardware. Virtual networks abstract physical networking. You configure subnets and routing without running cables. Block storage abstracts disk arrays. You attach volumes without managing RAID controllers. Platform abstraction hides operating systems and runtime environments. Managed databases abstract database installation, configuration, patching, and replication. You work with the database itself, not with the Linux server it runs on. Serverless compute abstracts the entire execution environment. You upload code, and it runs somewhere, somehow. You don't know what OS, what language runtime version, or what physical resources are involved. Software abstraction hides the entire application stack. SaaS gives you fully functional applications without any visibility into how they're implemented. You don't know what database Salesforce uses, how Microsoft 365 stores your email, or where Slack's infrastructure runs. The entire technology stack is abstracted away. You see features, not infrastructure. Each layer of abstraction hides more and requires less technical knowledge. IaaS requires understanding servers and networking. PaaS requires understanding application architecture, but not OS management. SaaS requires understanding the application's features, but nothing about its technical implementation. The progression is clear. More abstraction means simpler interfaces, but less visibility and control over what's actually happening underneath. Here's the fundamental trade-off abstraction creates: convenience versus transparency. Abstraction makes things easier. You don't need deep technical knowledge to consume services. You don't spend time on undifferentiated heavy lifting. You focus on your application, not on infrastructure maintenance. That's valuable, but abstraction creates opacity. You don't know how things actually work underneath. When performance degrades, you can't directly inspect the underlying cause. You're working through the abstraction, seeing only what it exposes. When providers make changes to implementations, you might not know until behavior changes. When something breaks, you're dependent on the provider to fix what you can't see. Abstraction also creates dependency. You're relying on the provider's implementation. If it has limitations, those become your limitations. If it has performance characteristics you don't like, you can't optimize the underlying system. You're stuck with how it's abstracted. And abstraction can hide costs. That simple launch instance click triggers resource consumption you're billed for, but the relationship between your action and actual infrastructure costs isn't transparent. The abstraction shows you a simple interface. It doesn't show you the economic reality beneath. The key is understanding what abstraction you're using, what it's hiding, and whether that trade-off makes sense for your needs. Sometimes abstraction is exactly what you want. Sometimes you need to see through it or work around it. Knowing the difference requires understanding what's being abstracted in the first place. Abstraction is the layer between what you interact with and what actually exists. It's what makes cloud computing simple, fast, and accessible, but it's also what hides complexity, limits transparency, and creates dependencies you might not want. And remember, every simple interface is hiding something complex. The question is whether you need to understand what's hidden or if the abstraction is doing its job. See you in the next one.